Welcome to Diksha Karnataka YouTube channel. Just let me fix the chat so that I can read your chat. Yes, so dual nature of radiation matter in the Chakravyuh series. As usual, it is also something important for your PU board exam, and we are going to discuss about 30 questions from this series. And if anyone is coming, let me check. Yes, hi Chandan, hi, good evening. So yes, so let me start with this stream now. So the first question, as usual, I generally try to keep the first question easy. Cathode ray particles are same as protons, electrons, alpha particles, neutrons. So obviously the answer to this question is obvious. Hi Vikas, hi MP Gamer, hi. Answer this question. Sir, this is for KSET DK boss. No, this is not for KSET. This is exclusively for PU board only. Okay, maybe some related concept can come in KSET, but this is focused for PU board only. Okay, KSET series we are doing in the master stroke series. I did a live today at 11 AM. If you have, I don't see you. So yes, Chandan B. Shivani, electrons, yes, electrons 1A. As you know, the rule for this class, you have to mention the question number and then correct option, right? And also, if you are confused, remember that electrons can only come out of a surface. So basically electrons are the answer. Now next question. Photoelectric effect was discovered first observed by. So this is very interesting. Most students actually answer this question incorrectly. Let's see if you can answer this question or not. This is a memory based question, pure memory based question. If you know the answer, you can answer. If you don't know, you cannot answer. Chandan is saying 2B, Hallwalk. So Einstein, Hallwalk, Leonard or Hertz. So there are 4 options. Vikas also saying 2B. DK boss, I cannot speak in Kannada in this lecture because our focus is on all types of students, and some students do prefer Kannada, I know, but some students also prefer English. So that is why we have kept our language preference in English in this channel. All the lectures you will find only in English. We do not speak in Kannada, but I can understand Kannada. If you have any doubt, you can ask me in Kannada. That is not an issue. Okay. Chandan R says Hertz. Okay, Shivani also says D, Leonard Hallwalk observation. So no, remember that Leonard and Hallwalk actually did the observations, but the first time it was observed by Heinrich Hertz. Okay, it was not Einstein, not Hallwalk, not Leonard. It was first observed by Heinrich Hertz. Okay, I think in somewhere around 1897. Later on, Hallwalk and Leonard did some experiment based on an old paper of Hertz, and they observed the phenomena. It was unexplained. It was left unexplained by Hertz, but it was published by Hertz first in a paper, and that is why the credit of discovering photoelectric effect goes to Hertz. Later on, Hallwalk and Leonard, they did a complete experiment, thorough experiment, and they listed down the observations. That is why we call it Hallwalk-Leonard observations. Later on, Einstein came into the picture and he explained the observations. The observations were completely not accordance with the current theory that point of time. So Einstein had to invent the theory which gave rise to the quantum mechanics, a complete new branch of physics. So that is why this is a very, very important concept. But you should know that first time it was observed by Heinrich Hertz. It was given in your NCERT book as well. So you have to be careful. So this is a trap question, memory based question, but trap question. Most students think Hallwalk and Leonard are the observations. So basically they both of them should be the answer. So this is the wrong question. Actually it is not. It was Heinrich Hertz. He did the first observation of photoelectric effect. He did it using UV rays. That also a important point to note. The sufficient energy by the electron to overcome the attractive pull of metal surface is called work function, photoelectric effect, stopping potential, field emission. Yes, DK boss. What fun fact? Leonard was chief of Aryan science in Nazi Germany. Yes, possibly. Yes. Actually, if you think around Second World War, lot of good discoveries happened in Nazi Germany, in fact in England, Europe also, but in terms of research spending, Hitler was way ahead. So that is why he was confident that I will win the war. But due to some unexpected development by USA, they discovered atomic bomb and etc. That is why it led to the downfall of Germany. Otherwise, there was some his way of rule was also very bad. But during the time of Second World War, a lot of good discoveries made which changed the science forever for us. Also, there was one more important thing, that Einstein was expelled from Germany because of Germans, Hitler's strong non-Yehudi principles. That's why he moved to USA, and USA got benefited from Einstein in discovering the atomic bomb. So there are some plus, some minus of that as well, but a lot of good discoveries actually happened. The way we do the fertilization, that is ammonium sulfate, that was discovered during First World War and Second World War. Okay, so it was discovered as a weapon, but later on it was realized the same thing can be used to fertilize the world. Okay, so there was a scientist, he was credited with, he killed the 50% of the population, and he also is responsible for the survival of the rest 50%. So that was a very good joke about him as well. I forgot the name, but that was also a good discovery. Yes, 3A. Yes, 3A is the answer. The answer is work function, not stopping potential. So student might be confused between work function and stopping potential. Work function is the energy. Stopping potential is the equivalent potential that is required to stop a moving electron. So stopping potential is not related to work function directly. There is a relationship, but not directly. It is related to kinetic energy of the electron. Okay, so obviously photoelectric effect, field emission does not matter. The name is work function. Next question, let's move on. Some alkali metals emit electrons when they are just illuminated by UV rays, visible light, X-rays, gamma rays. Okay, very interesting question. Yes, Fritz Haber. Yes. Thank you. You are a lot knowledgeable person. Sri Gauri is saying 4A. Yes, so as I said, it was first observed by Heinrich Hertz that he was doing some experiment with alkali metals, and he saw that when it was illuminated by UV rays, it is emitting electrons. So UV rays is the answer. It is not visible ray, not X-rays, gamma ray and X-ray will definitely give you. If UV ray is giving, then X-ray and gamma ray will definitely give, but UV ray is the lowest possible frequency, so UV ray we have to consider it UV rays. Okay, so they will illuminated by UV rays is the answer for this question. Next question, question number 5. Light of certain frequency and intensity incident on a photosensitive material causes photoelectric effect. The incident radiation is made exceedingly dim. Then what will happen? So light of certain frequency is falling on a metal. So light of certain frequency was falling on a metal and it was causing photoelectric effect. Okay, now you have suppose you had 100-watt lamp, 100-watt lamp of some UV ray, and it was causing the photoelectric effect. Now you made it to 1 watt. Will the photoelectric effect still continue or not? So that is the question. Photo emission will cease to exist. Photo emission will continue, but saturation current will decrease. Photo emission will continue, but saturation current will increase. None of the above. So easy standard question. Sri Gauri is saying 5C. DK boss, mention the question number. Mention the question number. 5B. Yes. Chandan is saying 5A. So you have to understand that photoelectric effect does not get affected by the intensity of the light. Okay, photoelectric effect will still continue. Only thing that will change is the saturation current. Saturation current is dependent on the intensity. Saturation current means was total number of emitted electrons, that will change. Okay, So what you have done, you have decreased the intensity. So decrease the intensity means total number of electrons that is getting emitted will decrease. So total number of electrons getting decreased means the saturation current will decrease. Okay, so photoelectric emission will continue, but saturation current will decrease. So option B is the correct answer, not 5C. Okay, so those who have answered DK Bose is correct as usual. So option B is the correct answer for this question. Okay, now next question. Okay, before going into the next question, we have launched KSET Abhyas KSET test series, which is currently live. For that, we have giving you 4 free tests. First 4 tests are absolutely free. You can get that by clicking on the link given in the description box. Once you click there, you have to register yourself. Then you get a link in your mobile. Using the mobile number that you use for registration, you can use that mobile number and register yourself. And then you have to download our Novo Parent app, and then from there you can access the test. Okay, you can also access it in your laptop, in your mobile, iOS, all the device supported. And if you want to purchase it right now, the offer is $14.99. that includes your PU2 preparation test series. So PU2 test series will be absolutely for 1 rupee only. If you don't want PU2 test series, $14.98 is the price. The current price is, obviously we have slashed it from 3,000. If you want to purchase it, go down in the link below and you can read all the description. I will explain it later in the end of this lecture. Now question number 6, the graph of photoelectric current versus intensity of the incident radiation for nu greater than nu naught. That means frequency is obviously greater than the threshold frequency. So what will happen? The graph of photoelectric current versus the intensity of incident radiation. A straight line with y-intercept, a straight line with x-intercept, a straight line passing through origin, a non-linear curve. So photoelectric current I versus intensity of light. Okay, photoelectric current versus intensity. What will happen to it? 6A. So what is the meaning of y-intercept? Y-intercept means is this. Okay, x-intercept is this, and straight line is this. Let's see. The frequency is fixed. Frequency is fixed. C. So intensity versus current graph. Okay, intensity versus current graph is basically a straight line passing through the origin. As you are increasing the intensity, okay, it will increase. Saturation current will increase. Okay, it is a straight line relationship. If the intensity is 0, no emission is happening. At 0 intensity, no emission can happen. This, remember that this is intensity versus current. Okay, frequency is completely not there. If there was a frequency versus current graph or any other type of graph, then you know there is a different kind of graph for intensity like this. Okay, but that is a potential versus graph. So potential, as you are increasing the potential in this, you call it stopping potential. So intensity, this is the saturation current. Okay, for different intensities the graph will be like this, right? But that is non-linear only for different types of graph. This will be a straight line graph passing through the origin, because at 0 intensity current cannot pass, and current and intensity are directly proportional. And here also it is given that frequency is greater than threshold frequency. Less than threshold frequency, the graph will not give you anything. Okay, so no current will pass. Other than that, it will be a straight line path. So C will be the correct answer for this. So most of you have answered it correctly except few of them. Yes, Yashash, DK Bose, Chandan, Chandan, you are changing your answer. First you answered 6C, then you are saying 6A. Okay, Sri Gauri also answered 6C. DK Bose also changed his answer. Meow also answered wrong. Now let's see this question. Photoelectric effect, the time lag of electron emission is 10 to the power of minus 10 seconds, 10 to the power of minus 5 seconds, 10 to the power of minus 8 seconds, 10 to the power of 5 seconds. So let's see. Yes, it is of the range of 10 to the power of minus 9 to 10 to the power of minus 10 seconds. So option A is correct answer for this. Okay, so the range is between 10 to the power of minus 9 to 10 to the power of minus 10 seconds, so almost instantaneous. Okay, so if you see an option giving you instantaneous, that is also the correct answer. Okay, so instantaneous or 10 to the power of minus 10 seconds. 10 to the power of minus 10 seconds means 1 by 10 to the power of 9th of a second. That is very less, right? So it is almost instantaneous. Now next question, the de Broglie wavelength of a moving particle is independent of dash of the particle: charge, mass, speed, momentum. Let's see. The de Broglie wavelength is independent of, yes, charge, 8A. Okay, anyone? Sri Gauri? Yes, it is independent of the charge. We know that de Broglie wavelength depends on the momentum. So momentum means, what is momentum? Momentum is basically mass into speed. So basically these three things are same thing. It is already dependent on mass and speed. Okay, and obviously it is dependent on the momentum. Momentum itself is mass into speed, so only independent of charge. Next question. Emission of electrons from a metal surface by heating is called photoelectric emission, thermoionic emission, field emission, secondary emission. Very interesting. So here we are using heating. Okay, let's see. 9B. Yes, it is called thermoionic emission. Thermo, you should remember, as I said, thermo comes from thermal. Thermal means heat. So thermoionic emission is heating. Okay, by light or by radiation is photoelectric effect. Photo means light. Okay, if it is happening with light or any kind of radiation, then it is called photoelectric emission. If it is happening by applying electric field, then it is called field emission. Okay, secondary emission, there is nothing called secondary emission. Okay, now let's move on. In the photoelectric effect experiment, if only the frequency of incident radiation is increased, then what will happen? So what you have done, you have increased the frequency of incident radiation. Okay, but intensity kept same. The maximum kinetic energy of the photoelectrons decreases, the stopping potential increases, the photoelectric current decreases, the photoelectric current increases, photoelectric current decreases. Okay, so what will happen to it? Yes. So Chandan is saying 10B. So stopping potential increases, right? Let's see. So we know that E into V equals to H nu minus nu naught. Right? This is the formula. This is the easiest, simplest formula for photoelectric effect to occur. So now if you see that if you increase nu, okay, this entire term will increase. Entire term will increase means now electron, charge of an electron is a constant. So only way to balance that means V has to increase. There is no other way. Now photoelectric current depends only on the intensity. It is independent of the frequency. As long as the frequency is higher than that of the threshold frequency, the photoelectric current, intensity of the photoelectric, it only depends on the intensity. It is independent on the frequency, right? But you have to remember that maximum kinetic energy always dependent on frequency. It is independent on the intensity. Okay, so there are a little complex combinations are there. So here, as you can see, because V has to increase, because you are increasing nu, that means stopping potential will increase. Also, if the same option was given, maximum kinetic energy of the photoelectron increases, that would also be a correct option, because what is the meaning of stopping potential? Stopping potential is basically stopping the highest energy of the electrons, right? So that means kinetic energy will increase, stopping potential will increase, but nothing else will change. Next question. Which experiment proved that the charge is quantized? Oil drop experiment, Davison-Garman experiment, alpha ray scattering experiment, Frank-Hertz experiment. So there was one experiment. The details of the experiment is no longer of the syllabus, but name is still there in your book. You can answer it. Yashas is Yashas, it was not 10C. 10, you got the answer right. It was stopping potential increases. So correct answer was 10B, not 10C. Okay, photoelectric current is independent. Now, yes, it is called Millikan oil drop experiment. Millikan oil drop experiment or oil drop experiment, which proves that charges are quantized in nature. Okay. Now, next. The particle behavior of light was confirmed by following experiment. A.H. Compton on scattering of X-rays from electrons, Albert Einstein for photoelectric effect, Millikan for charge of electron, J.J. Thomson's on discharge tube experiment. Choose the correct option. So the particle behavior of light, which of the following experiment was proved the particle behavior of light? Right, Compton's scattering experiment, Einstein's photoelectric experiment, and Millikan for charge of electrons, Thomson for discharge tube experiment. Choose the correct answer. Now, J.J. Thomson's discharge tube experiment was not part of the particle behavior of light. Okay, it was more like field emission. So option A, 1, 2, 3, these three are the experiment which was later on proved to be the linked experiment, which proved that charges are light is a particle in nature. So basically 1, 2 and 3 is the correct answer. So the little tricky question, this question I don't expect all of you to answer, that's why many of you are answering differently. You have to remember that Thomson discovered electron, charge per mass of an electron, but it was nothing to related, too much related to the particle nature of light. Okay, it was cathode ray experiment, so he applied some electric field and electrons coming out of the electric field, nothing to do with light. But Millikan's oil drop experiment on the other hand proved that charges are quantized, that is basically reverse of that of the light is particle. So particle is behaving like light, that means light can also behave like particle. So that is why Millikan's oil drop experiment is important. Photon energy is independent of intensity of radiation, frequency of radiation, wavelength of radiation, none of this. So photon energy is independent of which quantity? 13A, Shagufta, hi Shagufta. Sir, how to copy in finals? I cannot help you to copy. Only thing I can help you is to score out of out if you follow my lectures. Okay, there will be few more lectures coming up in next 1 week. So there I will be discussing how you can score out of out. You have to follow my lectures, then only you can write the answers. Don't rely on your friends. Okay, they will write the correct answer, but eventually they will tell you the wrong answers. Okay, I have seen that to happen in the exam. Okay, and many of the toppers they were confused in one of the 2 MCQs. Even if they have guessed, they would have answered it correctly, but they heard from their friends who tell them the wrong answer. They wrote it and they got 0 marks. So you cannot copy it. There are copy is art. I know many of the students, those who do copy, but when I was invigilating, they were not able to copy because I am a very strict invigilator. So they were complaining that, sir, you do very hard. Now, photon energy is independent of intensity of radiation. It is dependent on frequency. So basically photon energy is given by h nu, right? So nu is what? Nu is c by lambda. So it is dependent on frequency, dependent on wavelength, but there is no intensity term in the photon energy. So it is independent on the intensity of the radiation. Next question. In a photon particle collision, which of the following is conserved? Only the total energy is conserved. Only the so photon particle collision means scattering experiment. When a photon was sent towards an electron, okay, and it was scattered by some angle. Okay, the experiment was again, the details of the experiment is not there, only the name is there, but you can answer it by normal conservation in principle. If you apply the conservation principle, that is still applicable in photon particle scattering. Okay, so photon is basically behaving like a particle, and it is thrown towards an electron. Okay, then they interact, some energy gets exchanged, and electron starts moving. Okay, that is the scattering experiment. Electron scattering experiment. Only total energy is conserved, only the total momentum is conserved. Both total momentum and total energy are conserved, neither total momentum nor total energy is conserved. So what is the answer for that? 14C, Sri Gauri is saying, sir, first PUC maths important, please sir. Shetty, are you talking about first PUC? You are from first PUC maths class. We have already done all the maths passing package, maths first PUC model paper. Also we have done maths all important numericals formulas as well. So if you have not seen that, you can go and check that out. First PUC, everything is covered. Okay. 14C. Both total momentum and total energy is conserved. Momentum will always be conserved. You have to remember that momentum will always be conserved. Okay, and total energy is always conserved. Okay, kinetic energy may not be conserved, but total energy will always be conserved. So total energy will be conserved and momentum will be conserved. Okay, that is the backbone of this. Okay, when we move to in the graduation, you have to calculate the scattering angle. Based on that, lot of complicated mathematics is there for this scattering experiment. Okay, conservation of momentum, conservation of energy, both you have to apply and then find the angle of scattering, which was actually a fun mathematics. Anyway, the gathering and focusing mechanism of light by the eye lens is described by wave nature of light, particle nature of light, both A and B, neither A nor B. So what they are saying, that when we are seeing light through our eyes, so what and then focusing on our lens, retina, basically what is the what property of light is in exhibition over here. So they are saying wave nature, particle nature, both A and B, neither A nor B. So how does it function? So all types of answer I have received, 15A, 15B, 15C. See, first of all, let me neither A or nor B, obviously not possible, so this is not correct. Okay, now you have to understand that whenever light is entering our eyes, okay, in our class 10th also we have learned, even without the knowledge of the particle nature of light. Okay, so so basically it cannot be only particle nature of light, it can be both. It can be both. Okay, only particle nature of light is not the answer, because we have studied wave nature of light, that when we are studying only rectilinear propagation, that is basically ray optics, which is kind of wave optics obviously. So wave optics is wave nature of light is obviously correct answer, but both A and B is also possible in this case, but you can eliminate option B and option D. Option B and option D will not be the answer, either option A or option C. So option A will always be there. Okay, so wave nature of light is always there. Now our eyes, what happens, our cornea and there are cone cells, right, the different types of cells, and they are sensitive to different colors, they react to different things. Now maybe it is possible that it is particle nature of light is in exhibition, but particle nature of light is exhibition only when the light is interacting with equal amount of thing. Here it is only wave nature of light, in exhibition only wave nature of light. Okay, not particle nature of light. Particle nature of light is when when it is interacting with, maybe after it passes through the retina, particle nature of light can be there. It is basically converting into light signal to electrical signal. Electrical signals are basically carried from your eye to your brain, and then brain is interpreting that optical signals only, basically electrical signals only. Your brain can only interpret electrical signals. There is nothing separate. For example, if you eat something, you get a bitter taste. So that bitter taste is basically interpreted to an electrical signal. They are all related to electrical signal. Even your heart works on the electrical signals. Okay, so maybe there is some information I don't know, but eyes working can be perfectly explained using wave nature of light. We do not need particle nature of light, so only particle nature of light is sufficient. Okay, wave nature of light wave nature of light is sufficient. Particle nature of light is not required. So where we do not need any complicated things, we do not complicate the things. We keep it simple. Now, macroscopic particles in our daily life do not show wave-like properties. Macroscopic means, what is the meaning of macroscopic? Yash has already answered 16D. I just gave the question. Their wavelength is negligibly small. So what is the meaning of macroscopic? Macroscopic means large objects like you, me, your mobile phone, your TV, your laptop, your computer. Okay, so everything that we see around us are called macroscopic, that we can see in our naked eyes. That is called macroscopic. Microscopic means we need microscope to see things. For example, electrons, protons, they are microscopic. Even the germ that is sitting inside your blood, or if you are seeing it using a microscope, that means they are microscopic. Okay, so anything that you can see in your naked eyes are called macroscopic. Macro means big. Okay, macroscopic particles do not show any wave-like properties. So basically I cannot, even it is possible in science fiction, maybe you have seen some science fiction people becoming light waves and traveling from one place to another, but in reality that is not possible. Why so? Because even if we consider ourselves a wave, our speed is very small, our mass is very high, so our momentum is very small, and to achieve that level of wavelength, to have some wavelength, we have to move very, very fast, and our body cannot withstand that speed, right? So our wavelength for our normal behavior is very, very small, negligibly small, almost zero, not exactly equals to zero, but very, 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 very small. Okay, so wavelengths are negligibly small has to be the answer, not the zero. Though the number will come, it will be very close to zero, but that will still be a number, so you cannot say that is exactly zero. Exactly zero means exactly zero. Okay, even in 10 to the power of minus 34 meter for wavelength, that will also be not zero number. Okay, so you cannot say zero, it will be negligibly small. This question in from your 2024 question paper, and correct option was given option D, negligibly small. So I know many of you have answered correctly. Yashash, Soumya. Now let's see the next question. The absorption of light energy by retina of eye is described by wave nature of light, particle nature of light, both A and B, neither A nor B. Okay, so absorption of light by energy by retina. Same question, wave nature of light. Okay, next question. The value of E by M was found to be dependent on the nature of metal, independent of the nature of metal, dependent on the gas in the discharge tube, independent of the gas in the discharge tube. Chose to the correct option. So value of E by M. E by M is the mass of charge of electron divided by mass of electron. Now E by M for a given electron is a constant quantity. Okay, charge is known, mass is known, but E by M is constant quantity, is independent. It does not depend on anything. It is independent of metal, because E for carbon, whatever is the value, same E is for oxygen, same E is for iron or sodium. So whatever material you use, E by M for any material will be same. So it independent of the nature of the material, independent of the gas. Okay, so option 2 and 3 are the correct options. So 2 and 4. So option B is the correct answer. No, Yash has only answered correctly. Okay, so Chandan, not 18C. it will be 18b. Why? It does not depend on material, it does not depend on gas. Okay, so E by m is constant. E by m is constant no matter whatever you choose. The following statements relating wave theory to explain photoelectric emissions are statement number 1. So statement based questions are very popular these days. The maximum kinetic energy of photoelectron is directly proportional to intensity of light. Maximum kinetic energy and intensity. Does it making sound anything? The frequency of radiation does not depend on the photoelectric emission. So what is the statement? You think you think option A is the correct answer? See, maximum kinetic energy of the photoelectron does not depend on intensity. It does not depend on intensity, it depends only on frequency. So first statement is incorrect. First statement is incorrect. Now they are saying frequency is independent, does not depend. Frequency does not depend, does not change basically. The statement should be photoelectric effect is independent of the frequency, which is correct. Okay, which is not correct. So photoelectric effect depends on the frequency. There is a minimum value of frequency. If you are giving frequency light of below that level, there will be no photoelectric emission. So both 1 and 2 are false. Both 1 and 2 are false. None of them are correct. Okay, frequency, photoelectric effect depends on frequency, and maximum kinetic energy is only dependent on frequency. It does not depend on the intensity. Okay, so be careful answering such questions. So easy questions, but still you are not able to answer. Maybe you are just answering very fast. Read the question first. The slope of stopping potential V0 versus the frequency nu in Einstein's photoelectric equation. So very interesting question. Slope of stopping potential versus frequency graph. So stopping potential versus frequency. So frequency, stopping potential. There will be a graph, whatever graph it will be. I am not interested in the graph, but the graph will be like this only. Anyway, so you have to find the slope of this graph. So this is basically nu naught. Okay. So what will be the slope here? What will be the slope? Slope is delta y by delta x, right? Slope is delta y by delta x. Now what is delta y? Let's see what is y here. Y is stopping potential V0. So we know that we know that E V0 is basically equals to h nu minus nu naught, right? So what is V0 here? So V0 is basically h nu minus nu naught by E. Okay, so and what is delta x? You are plotting against nu, so what you have to do? V0 by nu. Okay, V0 by nu, that is h nu minus h nu naught by E into nu. Okay, so it will be h by or you can, what you can say, one more thing, sorry, you don't need to do it like this. There is one more way. How can we calculate slope? Y equals to mx plus c. So if we can write this equation in the form of y is equal to mx plus c, we can find the frequency. So what is y here? Y is V0. So V0 equals to h by E into nu minus h nu naught by E. Okay, so what is the slope here? M is slope, So from this equation, this is y, this is equivalent to y, and this is equivalent to x. So this must be equivalent to slope, right? So slope is h by e. That is option B, 20B. How many of you have answered it? Yes, Yashash answered it correctly. 20B is the correct answer, right? So you have to be careful, even though the question is slightly tricky. A cassette level question, I have seen the same question coming in the cassette. Maybe if the question paper decides to set a difficult question, they might give you this question. Now 21. In a photoelectric experiment, the wavelength of incident radiation is reduced from 6,000 angstrom to 5,000 angstrom. Then the frequency will decrease, stopping potential will increase, kinetic energy of the emitted electrons will decrease, the value of work function will increase. 21B. Yes. So if you see that frequency is basically c by lambda. So if you decrease lambda, your frequency will increase, right? So frequency 1 is actually less than frequency 2. So corresponding frequency to this one, say frequency 1, this is frequency 2. Now as you are decreasing the wavelength, frequency must increase. Frequency increase means, what do we know? The stopping potential will increase, kinetic energy will increase. Okay, frequency will increase. So frequency will increase, stopping potential increase, kinetic energy increase, work function is a constant for a metal. Okay, so from this option, stopping potential will be increase. Next question. This is a very interesting question. Which of the following figures represents the variation of particle momentum with associated with de Broglie wavelength? So momentum versus de Broglie wavelength. How does it associated with momentum and de Broglie wavelength? What is the formula for de Broglie wavelength? H by P, right? So de Broglie wavelength is H by P. So lambda P equals to H, that is constant. So what type of graph it will be? If you remember, there was one more graph like this, PV equals to constant. Okay, so PV equals to constant means its graph was rectangular hyperbola. Similar to here, it will be also a rectangular hyperbola. Only one rectangular hyperbola is given, that is option D, this one. Okay, this one will be only the correct answer. 22D, yes, Yashas is correct. Chandan, you misses, yes. Correct, Yashas is correct. So this is a rectangular hyperbola equation, xy equals to constant. You have learned another equation of hyperbola, I know that, but this is also a proof that show that this represents a hyperbola. So from the hyperbola equation you have to substitute the origin and then you can show that this is called rectangular hyperbola. Okay, you have to remember this. Now, emission of electrons from a metal surface by heating. We have, I think I have to change this. This one already answered, right? By emission of electrons from a metal surface by electric field is called photoelectric emission, field emission, thermoionic emission, secondary emission. 23B, yes, field emission. Okay, electric field is called field emission. In photoelectric experiment, if only the frequency of incident radiation is increased, then, so what you have done, only frequency of the incident radiation you are increasing. The maximum kinetic energy of photoelectrons decreases. I think I have answered this question. It is getting repeated. So only if you increase the frequency, the stopping potential will increase. Okay. Next question. Some of the questions are repeated anyway. Davison-Germer experiment proved wave nature of electrons, particle natures of electrons, wave nature of light, particle nature of light. Let's see. 25D. Davison-Germer experiment, Davison-Germer experiment, whatever you call it. No, Vishmay, it is not 25D. Davison-Germer experiment was wave nature of electrons. Okay, Davison-Germer experiment was wave nature of electrons. It proved de Broglie's hypothesis. Okay, so de Broglie hypothesis was a hypothesis, but Davison-Germer did the experiment and it proved the wave nature of electrons. Okay. Next question. Macroscopic particles in our daily life do not show wave-like properties because I think I have answered this question as well. Let's move on. The wavelength of matter wave is known as Einstein's wavelength, threshold wavelength, de Broglie wavelength, Newton's wavelength. Easy question. 27C. Yes. So it is de Broglie wavelength. So our session will be over very quickly. Field emission is emitting electrons on applying heat, electric field, magnetic field, light. Another easy question. 28B, yes, electric field, not magnetic field. Magnetic field cannot extract electrons, only electric fields can. Now photoelectric emission in emitting electrons on applying. Now answer this question. Photoelectric emission is second part. Another question, same question. So this type of questions are very common. Photoelectric effect, heat emission, then thermoionic emission, field emission. So these are all the common terms. They ask you whether you know these terminologies or not. Yes, it will be option D. So photoelectric effect is basically light, field emission is electric field. Now, question number 29. The de Broglie wavelength of a moving particle is independent of, I think it is also answered anyway. Let's see. Yes, 28D part 2 was the correct answer. Now this question, 29A, yes, it is independent of the charge. So this is a repeat question. Now, the following statements are related to photoelectric emission. Photoelectric current is independent of the intensity of the incident radiation. Stopping potential is different for different photosensitive material surfaces for a radiation of a particular frequency nu greater than nu naught. Maximum speed of photoelectrons is independent of the frequency of the incident radiation. Saturation current is different for radiations of different intensities having same frequency. So, is it independent of intensity or it is dependent on intensity? So, all the four statements, two of them are self-contradicting. Okay? Because in this statement it is saying that it is independent of intensity. In this question it is saying that it is depend on intensity. So, which of these is correct? 30D. So, option. Let's see which options are correct. This is an incorrect statement. Okay, it is not independent, it is dependent, fully dependent. That is verified by option 4. So definitely option 4 is correct. Stopping potential is different for different photosensitive materials. Yes, for zinc and copper it is different. For any two material if you take, they all have different photosensitive frequency. So work function is different. Okay, maximum speed dependent on the frequency. Okay, so that is stopping potential you say, or maximum kinetic energy you say. Everything is dependent on the frequency. So definitely this is also an incorrect statement. Only 2 and 4 are correct. So only 2 and 4 are correct statement. Now I have a small promotion. that is our Abhyas cassette test series. If you are following our channel, you should know that we have launched a particular dedicated test series aimed towards the preparation for your cassette 2025 exam. And if you are currently at the PU stage, then definitely you should want to purchase this test series, which is available for 1498 and 1 rupee for your PU2 preparation. PU2 you have launched one test series that absolutely almost absolutely free. For that only 1 rupee you have to pay extra, okay, which was launched at 600 rupees, 599. Later on the price was decreased, 499, but you can get that absolutely free, almost free for 1 rupee only, right? So if you purchase it right now, you will get this benefit of your PU2 preparation as well as your cassette preparation. Now if you wondering that when the test series will start, it will not start right now, it will start once your PU2 board exams are over, okay? So you will get 4 free tests right now. If you register only in the link below, you will get 4 free test series with the solution, and it will be like you can tap on the question and you can answer it. You can check how much you are doing correct. So it will be a timed exam format, okay? Also the PDF solutions will be given, the video lectures, video solutions will be given, and once the test series is launched, you will get chapter wise one-shot revision videos. You will get tips and tricks for last 5 years of cassette papers, what are we have analyzed, okay? Detailed video solutions, obviously with analysis you will get live sessions with the teachers, okay, where teachers will come and explicitly help you to understand whatever problems you have in your cassette preparation. So if you have any doubts, you can reach us. The link is given in the description. From there you can mail us, you can contact us. Right now you can get the 4 free test series just by registering yourself using a mobile number. Later on you can decide whether to purchase it or not, okay? So this is the promotion part. And then obviously if you have liked this video, don't forget to give it a thumbs up and share this video with your friend, and subscribe to our channel if you want more such videos from our side, right? Till then, bye.